Right, C34 June 2018, question 13. It's a differential equations question, separating the variables with some partial fractions. So here we go. Express 1 over 4 minus x, 2 minus x in partial fractions. So, right, something over 4 minus x plus something else over 2 minus x. Multiply through by this the denominator here, so we just have a times 2 minus x plus b times 4 minus x. Pick a couple of suitable values to sub in. We put x is 4 in, this term will go. So we'll have a multiplied by minus 2 is equal to 1, giving a is minus a half. If we put x is 2 in, this term will go. I'll just have 2b here, so b is a half. So in terms of partial fractions, I can write like that. I'm not keen on fractions in fractions, but it turns out it's more convenient this way, I think. You could put that 2 on the bottom. So that'll be minus 1 over 2 times 4 minus x. We're going to leave it like this. Right, then it says the mass, x grams of a substance at time t seconds, chemical reaction starts, is modelled by that differential equation. We've got a constant there, and then we've got these two terms that look a bit like what we just had before. So standard procedure, separating the variables. I'm going to put the dt up here, so I have k dt, and these are two x terms. We're going to divide by those. So I'll have 1 over 4 minus x, 2 minus x, and this is where we're going to use the partial fractions, and then integrate both sides. So right, this is in terms of the partial fractions. I would integrate it. Equals k dt. This term here, well, I've got a minus there. If I do the ln of 4 minus x, if I differentiate that, I do get a minus on the top. So this one is just going to be a half of ln 4 minus x. If I differentiate this, I will have a half times 1 over 4 minus x multiplied by minus 1, which does give me this. This one, though, if I do the ln of 2 minus x, I get minus 1 over 2 minus x. So if I integrate this, it needs to be a half, minus a half, ln 2 minus x. The other side is just a constant, just a number, so it's going to be kt, and then I need a constant on the right hand side. If I put my initial conditions in, t is 0, x is 0, I'll have a half ln 4 minus a half ln 2 is 0 plus the c. This really is a half of ln 4 minus ln 2, so it's just a half of ln 2, because I do 4 divided by 2. So this is what I've got for me. So this is the particular solution of the differential equation. We've got to get into that form. So I'll get rid of the ln's first by getting all the ln's on one side and multiplying by 2. Get rid of the halves really. So I'll have ln 4 minus x minus ln 2 minus x minus ln 2. So the 4 minus x on the top and the 2 minus x and the 2 on the bottom that's equal to 2 kt. So e both sides. So this fraction is equal to e to the 2 kt. And then I'm going to try and get to say x equals. So I'll multiply by that bottom line. 4 minus 2x multiplied by e to the 2 kt, and I get this. I want the x term on one side, so if I take this term over the left hand side and the x term over the other, I've got the 2 x terms on this side. I can take it out as a factor and then divide by that bracket, and I get x equals what it says. And then the last part, given that k is equal to 0.1 for the value of t when x equals 1, give you an answer in seconds. It's tempting to use the expression that we've got here, putting x equals 1 and then work out t, but we've already got almost got t in terms of x here, because we want to know what t is when x is equal to 1 rather than what x equals. We want to say t equals really, but if I use this one, I'll put in x equals 1 into here. I'll have 3 on the top and 2 on the bottom. So the t is going to be ln 3 over 2, all divided by 2k. So 1 over 2k multiplied by ln 3 over 2, which is 2.03.